Welcome back, Recruit. Now it's time to discuss another Python basic object, which is a dictionary. Dictionaries are unordered mappings for storing objects. Previously, we saw how we could use a Python list to store objects in an ordered sequence, such as storing integers or strings in order. Dictionaries, however, use a key-value pairing instead. This key-value pair allows users to quickly grab objects without needing to know an index location. Dictionaries, as far as their syntax, use curly braces and colons to signify the keys and their associated values. So you'll have a set of curly braces at the very outside, and then you have key, colon, and then the value that goes with it. Here we're showing strings as the values, but you can also have dictionaries, numbers, lists as the values themselves. And then we separate each key value pair with a comma. Now you may be asking yourself, when do I choose a list and when do I choose a dictionary? Well, to put it simply, dictionaries have objects being retrieved by their key name. That is, if you want to grab value number 1, then you just pass in the key that's associated with that value. That may seem really convenient, but the issue here is that the way the key value mapping works is dictionaries remain unordered and you cannot actually sort them. If you wanted to be able to sort, maybe you want to reverse or organize your actual objects, then you would need to use a list because objects there are retrieved by their index location. And because they're a list, that means you can have an order sequence that can be indexed, sliced, or sorted. So it's basically a trade-off here. Dictionaries allow you to retrieve by a key name, however, you can't really sort them. Lists allow you to retrieve by location, and then the added benefit is that you can index, slice, or sort the list. Let's explore these concepts further in a Jupyter notebook. Let's start off by creating a dictionary. We'll name it variable D. We have our curly braces, and then we create a key. We'll have key 1, just as a string, and then a value. We'll say value 1. Then comma for another key value pair. So key 2, and then value 2. Then if I want to retrieve values, I can just use their associated key. So I can pass in key 1 to return value 2, or if I wanted value 2, then I can just pass in key 2 and grab value 2. If I ever want to add a new key item or key value pair, all I have to do is call my dictionary variable, create some new key, and then set that equal to whatever item I want to pass in. So I'll just pass in a new string here called new item, and then if I check out my dictionary, have key 1, value 1, key 2, value 2, new key, new item. Now I want to make it really clear here, dictionaries are unordered. And this may not be clear at first with smaller dictionaries because it seems like you're just adding in new key item pairs in order. So let's show an example to really prove to you that dictionaries are unordered mappings. When you add in new key item pairs, you're not guaranteed to know the location of them, which is why indexing or slicing is really invalid for dictionaries. That concept doesn't really make sense for key value pairs because we're not going to know their actual order. I'm going to create a new dictionary here where I have key A and its value is the number 1, key Z and its value is the number 2. So if I take a look at my dictionary, A is to 1 and then Z is to 2. I'm going to create a new key called new and then set it to the value 0. And now if I look at my dictionary, when it reports it back, it's not reporting it back in the order that I added the keys in. It's just reporting back the actual key value mappings, A1, new 0, and Z2. So hopefully this makes it pretty clear to you that the dictionary is an unordered mapping and you are losing the ability to sort or call with indexing. If you need that ability, you'll need to use a list. I should also mention that dictionaries are very flexible in the data types they can hold. So to prove that to you, I'm going to make a larger dictionary here. We'll have the first key just be K1, and keys are just always strings, and then the values can be quite flexible. So we can see here 10 is that value. We'll have key 2, we'll give it stringy, a string as another value, and then let's create another key, K3, and we can even have a list here, 1, 2, 3, and then we can even have a dictionary inside of a dictionary. So we can say K4, is equal to another dictionary inside matched with the number 100. And now I can see kind of a complex dictionary, so let's take a look at what all the keys are holding. So K1 is holding the number 10, K2 is holding a string called stringy, K3 is holding a list, 1, 2, 3, and K4 is holding, well, what should we just call K4, is holding another dictionary, and I can actually stack key value call, so if I wanted to grab the number 100, I could type in inside here and grab the number 100. Keep in mind that you will get an error if you ask for a key that is not present in the dictionary. For instance, if we ask for oops, which we know is definitely not a key in this dictionary, you'll get back key error, and hopefully this error is pretty obvious. It's just saying key error, it can't find that key inside your dictionary. Let's show you a more realistic example of when you would use a dictionary. As you may already know, every United States president has a Secret Service code name that's assigned to them. So we're going to create a code names dictionary, and we'll have curly braces here. Obama's code name was Renegade, and you can check out the notebook that's associated with this lecture for the source on this. And then Bush's code name was Trailblazer. Whoops. Reagan's code name was Rawhide. And then Ford's code name was Passkey. And notice here I can actually type this out over multiple lines because it's all being contained within these curly braces. Remember that you're going to need these commas here to separate out the key value pairs. So now that we run this, let's imagine that I quickly wanted to know what the code name was for President Ford. Well, then we would just pass in code names, pass in the Ford key, and I would quickly get back his code name. So here's a pretty good example of why we'd use a dictionary. Basically, anytime you want to quickly store information where key value pairs make sense. Maybe you want the populations of countries. So you say USA, its population in millions is about 323 million. Population of Germany is about 83 million. And we can say population of India is like 1.3 billion. So we'll say 1,324 million. And then if you quickly wanted to know, well, what's the population in millions of the United States, you can just use a dictionary to quickly retrieve that information. This sort of data structure makes a lot more sense than using a list, which essentially just the ordered sequence. Finally, I want to discuss some key methods that are available to you off a dictionary. And that is, if we look at this dictionary population, actually let's look at the code names dictionary. If I look at the code names dictionary and I want to know all the keys in that dictionary, I can run keys and get back Obama, Bush, Reagan, Ford. If I wanted to get all the values of the dictionary, then I get back the actual values. Notice here it's not telling me what keys are associated with what values. If I wanted that connection, what I could do is say code names and then call items. And that gives you back this object where in what's called a tuple or tuple, the actual matchings, Obama, Renegade, Bush, Trailblazer, etc. So great work so far. We're actually almost done with your basics bootcamp. You just need to learn about sets, working with files, and you'll be ready for your first field readiness exam. I'll see you at the next lesson.